Hey, welcome back to Math with Patrick and Quill. Today is November 10th, and we're solving problem 314 from the Daily Epsilon calendar. And today we should show why x is 10, because that's today's date. So we have some kind of like fraction and exponent like arithmetic or algebra problem today, I guess, where we need to show why 10 makes sense as the exponent on the left side, and that we get this kind of weird fraction on the right, 1,048,575 over 1,024. Now I do recognize this number, I just know that this is 2 to the power of 10. And this top number is like suspicious to me. I think it's another kind of special number here, but I'm not quite sure yet. So anyways, let me see if I can do some like algebra steps to simplify the exponents on the left side. The first thing that I'd like to do is get a common base going. I'd rather have 2's everywhere instead of 4's and 2's. So I could rewrite the 4 as just 4 squared like that. And then there is an exponent rule where I can multiply these stacked exponents. So I can replace 4 to the power of x with 2 to the power of 2x, and then minus, and then this will turn into a 2 to the power of negative 2x. And I'll just keep the bottom the way it is for now. And usually finding a factored form is good here too. And I'm going to do something a little bit weird, and I think I'm going to choose to factor out a 2 to the power of negative 2x from the top, and then a 2 to the power of negative x from the bottom. The reason being is just that I think if I turn this number and that number into 1, it'll be pretty useful. And distributing here, I do get that. And then so I can get a -1 on top, a +1 on bottom. And then I do need to put some kind of 2 to the power of something here to get back to this one after distributing. I'm kind of thinking of this exponent rule where when we multiply with common bases, and I have some kind of mystery exponent right here, these two are supposed to add to that one. And so I can see that this should be a 4x right there. So I'll put a 4x. And then on the bottom, similar idea, this will turn into a 2 to the power of 2x. And again, my overall goal here is just to like factor, simplify, see what I can do. And there is actually something here where this factor right here is a difference of squares. And finally, I'll actually get some kind of convenient cancellations here. The difference of squares factoring tells me that this number right here could be written as this one instead, where I have a plus on one side and a minus over there. Again, if I redistribute all this stuff, I will just get exactly where I came from. And the idea behind this factoring is that it does actually conveniently cancel with this factor on the bottom. So we can just go get rid of these. There's no chance that this is the number 0, because this is always positive, and then +1 makes definitely an always positive number. So I'm not kind of making any mistakes by dividing by 0 here. And this does simplify my fraction a little bit more. Maybe let's do one more exponent rule on these guys to kind of smush them together. Normally, when you have the same base and different exponents in a fraction like this, you can just subtract those exponents. And so if I do subtract a 2x, or rather subtract a negative x from a negative 2x, it's almost like adding instead. And so I could rewrite this as 2 to the power of negative x times, and then this factor over here. Although, just to get rid of negative exponents, final exponent rule, I think, I am going to put this in the denominator and take off that negative sign. In short, negative exponents essentially tell you to divide, and so putting it in the denominator without the negative sign kind of covers the same idea. So I think I simplified the fraction a lot, right? Like we started out with 4 different terms, the power or the bases were different, and now I have something that's a little bit more simple, and so I will put that somewhere up top. That was 2 to the power of 2x minus 1 over 2 to the power of x. And so here I'm noticing, okay, maybe I could just say x is 10. As long as I'm able to show that this number up here, plugging that 10 in right there, that number is supposed to be 2 to the power of 20 and then minus 1. Now, 2 to the power of 20 will take a while to compute if we just think about it as 2 times 2 times 2 times 2, 20 times. However, we can use an exponent rule we used earlier, just in reverse, where I could actually, maybe I'll rewrite it like this, where, again, I could just multiply this x and the 2 to get to the 2x that I had before. But this makes it easier for me to see that 2 to the power of 20 should just be 2 to the power of 10 squared. And okay, I guess I should show that these two things are equal. And then finally, once I do prove that these numbers are the same, I could just square 1024 to figure out what 2 to the power of 20 is. So let's just count by our powers of 2 until we get to 1024. It's 2, 4, 8, 16, 32, halfway there. 64, 128, 256, 512, and then finally 1024. This is 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2 to the power of 10. Cool. And then we just need to show that squaring 2 to the power of 10 and subtracting 1 gives us this number right here. So let's try it out. Let's do just some kind of long multiplication right here. Give me a sec. This is 16, that's 9, that's 0, that's 4, placeholder 0. Double 1024 is going to be 2048. This is just 0 all the way across, and then a triple placeholder 0 for my 1000, and then I'll put 4, 2, 0, 1. Adding these all up, that's 6, that's 7, carry the 1, that's a 5, that's an 8, that's 4, 0, 1. And if you'll notice, we do have the exact same number, except this number is a 6, and this number is a 5. So that does mean once we do subtract the 1, we will get the 5. So this to me shows that x should be 10. That satisfies the problem. It lets us get equation, and I think we are all done. So thank you for watching. I'll see you tomorrow. Bye.